now, just so you know. Always like to warn you. Okay, so I'm going to go over to the agenda so you can see what we're doing here. Here's my teams. Here's my teams. Okay, now this right here, C3, Chapter 3, Lesson 5, Part 1, I asked you to watch yesterday. If you haven't watched it yet, that's okay. You can still watch it after I show you the algebra today. But we've got lots of notes and examples today because you have to remember stuff from Algebra 1 before you can do equations of parallel and perpendicular lines. So I've made this little algebra review for you, which we're going to watch this together now. If you would like to fill in these notes as we go along, they're in your class notebook. Okay. So you might want to open this up and or print them out if you can do that. Under the content library. Whoops. But one note, it's right here, lines in the coordinate plane. Okay. These, and then those examples we'll do tomorrow. Examples we'll do tomorrow. Okay. So it's right here, lines in the coordinate plane. And like I said, this video just fills it all the way out and shows you how to do that. And we're going to do that together. So get that if you want to get it. And I'm going to go ahead and go back to the agenda. I'm going to share my screen. Again, this is on my YouTube channel, so you wait. And then I'm going to turn on the microphone. I keep forgetting to do that. Actually, could you hear me talking already?
Yeah.
Oh, good. Then I don't, well, now that I opened my tray, I have to redo it. Okay, so I think we're good. So follow along. Some of you are going to know this already for sure. And some just need
You're glitching out.
You can zoom through it. If you don't, it never hurts to get some review in. Okay, so I'm going to start here with our objectives. We're going to talk about lines in the coordinate plane, obviously. And I will be able to determine if lines are parallel or perpendicular using only slopes. I'm also going to be able to write equations of lines that are parallel or perpendicular to a given line, which is usually how we see this type of problem. So slope refers to a number describing the steepness of the line. Any 2 points can be used to determine the slope of a line. All you have to use is the slope formula. So we call slope M. I still have no idea why. I think S was already taken. And we refer to our 2 points as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You may also have heard this as rise over run. You have to rise out of bed before you can run across the street. Okay, and so here's an example. If you use the slope formula to determine the slope of the segment GH, I would just denote this as the first point, x sub 1, y sub 1, and this is x sub 2, y sub 2, and then I would plug it into this formula. So the slope is equal to 5 minus 3 divided by 7 minus 2. I would simplify, I get 2 over 5, and that is the slope. So it means that from any point to another point on a line, you would go 2 up and 5 over. That's what that means. So just as a review of what slope looks like, there's only really 4 possibilities here. A positive slope goes in this direction. In other words, it goes from lower left to upper right. And you should think of this as going up a hill. This is like uphill. A negative slope is like going downhill. So it looks like you're going with this. It's always left to right when we read graphs, just like we read a book. Another one in particular is zero slope, which means no slope at all. Okay, so a zero slope looks like this, straight across. And part of the reason for that is that there's zero rise, which means any number that goes into 0 is going to give you a 0 slope. And then finally, anytime you have something like this, that means undefined, because there is no hill here. We can't climb up this, but also because if you look at the definition, any number divided by 0 is not okay. Remember, we get an error if we do it in our calculator, and so we say it is undefined. So now that we're done with that review, hopefully remember positive, negative, 0, and undefined. So there's a couple of things that you might remember from algebra called the slope-intercept form. It has a slope and an intercept. I know mathematicians were very creative. And guess what the point slope has? A point and a slope. So this equation is y equals mx plus b. This is like the x-axis, and this is like the y-axis. M refers to slope, and the b refers to the y-intercept. So these are just numbers, right? Those are numbers that we would figure out. Now the point slope form has any point x sub 1, y sub 1, and the same thing, a slope. So here's what it is. It's y minus y sub 1 equals m times x minus x sub 1. So our m is the same. We're still talking about the slope of the line, but your x sub 1, y sub 1 just means a point on the line, and it can be any point. So again, those don't mean an operation, it just means that particular point. So again, this is the x-axis, and this is the y-axis. You don't put numbers in for that. You only put numbers in for this specific one. So here's what we're going to do. Again, we're going to review just a little bit from algebra. There were a number of different ways you could have learned how to do this. So I'm just going to follow the directions here. This is in slope-intercept form because I can see my slope here and my intercept here. So what you do is you start with the intercept, and that is on the y. So you put a 1 on the y. Remember, this is x and this is y. Now from here, I'm going to count out the slope. The slope is -3. You always go rise, and this is equivalent to over 1. So that's a rise of -3, which means you're going to go down 1, 2, 3, and then that's a run of 1 positive. You'll do it again from that point, 1, 2, 3, and then you'll go 1 positive. And the neat thing about the way you can graph these is you can also do +3 over -1. So from that point, you could go up 3, but then you would go back 1. And you know that that will always connect, okay? Make sure you connect your points with a straight edge, so you have your straight edge handy at all times. It can be your ID card or a popsicle stick or a ruler. That's how you do that. So we'll do another example. Let's see if you can follow along. First step, B goes on the Y. So -2 starts right here, 1, 2. Then we look at 3/4. That means we're going to go 3 up and 4 over from this point. 1, 2, 3, 1, 2, 3, 4. Now, one thing to notice is that positive 3/4 is also the same thing as -3 divided by -4. So from this point, you could go the other direction. Down, 1, 2, 3, and then back, 1, 2, 3, 4. I like to go both directions to make sure that I don't make a mistake. Of course, technically you only need 2 points, but I like 3 to make sure that I'm in the correct direction. Another thing I really like to see is if you get in the habit of drawing the equation right on the line. This is -3x plus 1. And then this one is y equals 3/4 x minus 2. And just to check, negative slope, that direction, positive slope, that direction. Now we're going to do a second method called the point slope form. It's right here, so I'm going to turn the page over, and here we are. Point slope form looks slightly different. It's just a different form. But what it is instead of the y-intercept, what you have here is a point. So you get a point and a slope. So we're going to start with this point, and here it is. This is your x1, and this is your y1. So you're going to start at the point 1, -3. 1, -3, 1, 2, 3. That's our point. And from there, you're going to use this slope of -2. So just like we did before, you go down to +1. Or from that same starting point, up 2 and back 1. You could do it all the way up if you wanted to make sure that you're all in a straight line. And then you connect your points with a straight edge. If you can do excellent work, I expect you to. So some of you may want to just eyeball it and not use the straight edge. Don't do that. Okay, so here's my y1, here's my x1. So I start at this point, and this point is -2, +1. So -2, +1 is right here. And then again, I'm going to use this slope, which is -2/3. So from here, down 2, 1, 2 over 3, 1, 2, 3. Down 2 over 3. Again, I could also do the opposite direction. I could go up 2, but back 3. And all of my points line up, and I connect them with a straight edge. Okay, so again, algebra review. I can feel it coming back to you right now already, whatever you had for last year. So a vertical line is straight up and down. Those are the undefined ones. And the horizontal ones are like this. Those are the zero slope. So the equation of the vertical line is a special form. It is always x equals some number. And x equals that number, where the number is the x-intercept. So example, x equals -3 is a vertical line. It would be up and down on the line where x equals -3. A horizontal line, sideways, has an equation of y equals a number, where that number is the y-intercept. So an example would be y equals 2. Now what we're going to do with all this geometry, this algebra review, is we're going to connect it to geometry. So for section 5, in a coordinate plane, 2 distinct non-vertical lines are parallel if and only if they have the same slope. Also, any 2 vertical lines parallel. and perpendicular lines theorem. You should have seen this already in yesterday's video. If we have in a coordinate plane two distinct non-vertical lines being perpendicular, if and only if, the product, meaning when you multiply their slopes, you get -1. That means they're negative reciprocals. So some of you might think of it this way. Go ahead and add that onto your notes, negative reciprocals. And then what we're going to do for each one of these is we're going to determine which ones are parallel and which ones are perpendicular, which means you've got all these points and 4 lines. We're going to figure out the slope between each 2 points. So I'm going to call this one, line 1, so that the slope of 1 is going to equal, here's my x, here's my y, here's my x, here's my y. So y2 is 3, y1 is 2, x2 is 0, x1 is -3, so I'm going to add 3. And that gives me 3 minus 2 over 3. Now for line 2, I'm going to call it m sub 2. Let's start with my y's. 0 minus -1 over 2 minus 0. So that's going to give me 1 on the top and 2 on the bottom. For the third line, slope is the y's, 2 minus 1 over 2 minus 1 of the x's. So I have 1 over 2. And then my fourth one for my fourth set of points is the y, 2 minus y1 over x2 minus x1. So 2 over -1.
Sorry, I didn't realize that didn't show me the camera.
You could also have that as -2. So here's what this is going to look like. These two have the same slope. Oh, here we go. So since M2 and M3 have the same slope, then they are parallel. So M2 is parallel to M3 since both of their slope, since slope is 1/2. I'm looking, M3 is 1/3. There is no relationship between M1 is 1/3. There's no relationship between M1 and anything else. But if you do -2 times 1/2 here or here, you will get perpendicular. Okay, so what that means is M4 is perpendicular to M2 and M4 is perpendicular to M3. Since -2 times 1/2 equals -1. That's how you show that. So they both have the same slope. And this is, again, something we're going to try to recall in Algebra 1. And we're going to be using these exact methods in the geometry problems for 3.5.
Okay, so we've now gone over everything you need to start Chapter 3, Lesson 5. I'm going to have you look at the feed here. So if you didn't watch this from yesterday, you still have to do that. And then today's assignment, I've been giving you like 2 days. It's actually due tomorrow. So in the general, as you can see, it's right here, part 1. I think it's only 5 problems, because I broke it into 2 parts. So what I'd like you to do is go and do this part on your own. Between those two videos, you have enough examples and algebra review. And then tomorrow, I'm going to do a few more examples, and part 2 will pop up. And that'll be due by Friday. Because again, we're wrapping up this chapter. So we're spending a couple of days on it. I think that's probably enough for the recording for anybody